Hi everyone! We are nearing the end of the semester and we're nearing the end of our polynomials unit. The next two lessons, 16 and 17, are going to be dedicated to polynomial graphs. And I just want to give a warning that the next two lessons, 16 and 17, they're going to be kind of a hodgepodge of different polynomial graphing concepts. So, to make it as nice as possible, each concept in your notes is going to correspond to a skill in your homework. So the name of each concept that's highlighted, that's the name of a skill directly linked in Delta Math. So when you go to your Delta Math and you read the title of the skill, you're going to come back to your notes and find that highlighted as a concept. So that's how this is going to go. But all of these skills are related to either graphing polynomials or the graphs and identifying items from polynomials. So our first concept that we're going to talk about is finding roots from a graph. Remember, when we ask for the roots of a graph, we are looking specifically for the x-intercepts. So we have two examples. The graphs of y equals f of x are shown below. What are the real solutions of f of x equals 0? So all you need to do is just go through your graph and just identify the x-intercepts. So this first graph, we have 3 points that either touch or cross the x-axis. Those are our intercepts, meaning those are our roots. So now we're going to actually identify them. So this first one is at -8. This second one is at -4. And we have our third one at 5. So that's all we're doing. We're just listing the x-intercepts. For our next one, again, we just identify on the graph our x-intercepts. Here we have 3 x-intercepts, and now we're going to identify them. The first is at -5, the second is at 0, and the third is at +8. Now, as you may notice, I just listed them as numbers. I did not list them as points. So in Delta, listing the numbers is what is wanted. So, normally we would list our x-intercepts as coordinate points. In Delta Math, they just want you to list the numbers of the x-intercepts. Now, that's going to be a different story for our next concept, finding y-intercepts of polynomials. So, remember, to find the y-intercept of a function, all you need to do is plug 0 into x and simplify. This one, you are going to write the y-intercept as a coordinate point at the end. So, just be aware of that. So, for our first one, this is what we call unfactored form. So all you have to do is just replace all the x's with a 0. So -2 minus 7 times 0 minus 6 times 0 squared plus 3 times 0 cubed. And then simplify. What's nice about the unfactored form? Well, all these zeros just end up canceling them out, so we're left with -2. So our y-intercept is going to be at 0, -2. Remember, it needs to be written as a coordinate point for the y-intercept. All right, our next one. This polynomial looks different. This is what we call factored form. But even though it looks different, it's the same concept. We're going to plug 0 into x and simplify. So here, this 2 is left alone. 2 times 0 is 0, so these zeros get canceled, but we still have things that don't get canceled out. So we're going to have 2 times negative 3 times positive 5, and we get negative 30. So my y-intercept is at 0, negative 30. All right, that's just the beginning of our hodgepodge of polynomial graphs. See you in the next one.